So, as you mentioned, my name's Ed. Here to talk about DevOps, and what we're really going to talk about is some research and development we've been doing in the open source world of how we apply this to network defense, apply DevOps to network defense. So the first comment I'd make is that we're getting beat by the offense, and we really looked at why we're getting beat. Dan and I and a bunch of us in the company have worked on exercises for a while, offense side, defense side, analyzing where the gap is. And we've realized the significant gap between offense and defense is in the speed. The offense is very fast. They're changing their tactics. The time that they deploy new capabilities is instantaneous. As an example of that, Carnegie Mellon did a study about the Scalability malware that came out of China. They realized there were 200 unique builds of this malware in 1 year, right? That's 4 or 5 builds per week. That's huge. The offense side is changing rapidly. Now, how long does it take us to roll out a new capability on the defense side? We want to push out a new firewall or a new IPS. It can take us months, sometimes years. And that's a problem. That's something that we need to try to figure out how to solve. So the application development world has already kind of solved this with this thing called DevOps. Automated provisioning, continuous building, continuous integration, continuous delivery. These are all cornerstones of rapid deployment of capabilities. The problem that we've got in the DCO and the defensive side is that all of our tools right now are basically appliances, right? You want to buy a new firewall, it's an appliance. You want to buy a new intrusion prevention, it's an appliance. Your new event management, you name it, ArcSight or Splunk or whatever, they're coming as appliances, and they require touch labor to go out and deploy. So it takes us a few months or a year or two to deploy these new capabilities. By the time they're deployed, the bandwidth has already increased, and what you bought is obsolete. And you're literally doing this tech refresh process every 5 years, and by the time you finish deploying something out, it's already obsolete, or you have to upgrade to the next model. So we looked at it over the past year, and we said, how could we get better at this? We said, okay, we need a couple of different concepts. One, to beat the bandwidth problem, we need to be able to scale out horizontally and rapidly scale out. So that if we go from 10 gigs a second to 40 gigs a second, it's not a problem to add new nodes. Okay, you're not ripping and replacing everything. Multi-tenancy is a big thing. I know a bunch of us have worked on at SealingTech have worked on the JRSS program for a while, and multi-tenancy is always a key problem. We want push-button deployment of applications. Meaning a new IPS or IDS or firewall, you should be able to push a button and have it instantly deployed out to your entire enterprise, or swapped out. If you currently have one IPS, like let's use an example, a Tipping Point or a Palo Alto, and you need to upgrade to the next version or model or upgrade to a different vendor, you should be able to hit a button and have it rip out the old one and put in the new one. This is the Department of Defense. Once the cyber war comes on, everyone would say it's already here, but these are offense and defense at a national state level. So the military is going to have to develop their own capabilities. I think our partners across the fence over at the other agencies are deploying their own in-house built capabilities. So we need to be able to handle both civilian and military tool sets. And then when you get to that scalability, you should be able to scale down to small bandwidths, let's say a tactical node, or large things, again, like 40 or 100 gigabits per second. Okay, so we looked at this problem internally, mulled it over for a while. We brought on a team of interns last year to kind of, last summer, to really hit this problem hard and come up with some ideas. We came up with 2 big ones right off the bat. We need to split the platform from the apps, okay? The platform should be able to provide all your services of scalability, your multi-tenancy. That's a platform thing. The apps should be separate to ride on top of that. Then we need to look at remote repositories, again, app stores. If you want to deploy something new, you should be able to bring up the Army's DCO repository, see the tools they're developing and say, I want that one, that looks good. Or NSA's got this app repository, they've got this new tool out, I want that one. So we started with the bare metal, like any good cluster. We layered on top container engine and virtual machine engine, right? We want to do things virtually. So we use both containers and virtual machines. I've got a whole bunch of slides that I don't have time to talk about of why containers versus virtual machines. But we then needed a dynamic cluster manager, something to orchestrate all these apps together. By the way, I'm not selling a product here. This is all internal research and development. We're going to be open sourcing all of this at the end of the week. So just FYI, I'm not trying to sell you anything here, except for these great ideas. All right, so those areas make up the platform, and then the apps go on top of that. I skipped the networking layer. We layered on an overlay network, which is I struggle to say software-defined networking, but it's an overlay network that stitches everything together. Then we wanted to bring in a marketplace. So what this really gives us is the ability to have a develop, stage, and push anywhere of just the apps. An app being an intrusion detection or a layer 7 firewall. We put those apps into a repository, and then once you've got your generic clusters out there, your clusters of servers, then you can push from that repository out globally a new capability all at once. Our goal here was we wanted to be able to handle lots of bandwidth, right? 100 gigs per second. DISA right now is rolling out a 100 gig backbone. I think there's a real problem right now with how to handle that in terms of throughput. The only way to do that is scale linearly. The testing that we've done so far that Dan's going to talk a little bit about does scale linearly, meaning if one node can do 3 gigabits per second of inspection and event analytics, then 2 can do 6, 3 can do 9, etc. 35 nodes can do 100 gigs. So this scale horizontally concept is really a crux to what we need to get to in the platform side. Again, not talking about the apps, but the platform. That gets really complex. There's a reason that hasn't been done before very often in C&D, in network defense. And that's really because you have to do these fancy things like symmetric load balancing and heartbeats all the way through all your virtual machines. But it is possible, and there are tools out that are just coming out now that allow for that. So when we look at this whole scalability thing, we can go down to a single node. Now, you'd say, why a single node in the DoD? I mean, it might be doing 2 gigabits per second, that's not a lot. But the key here is that you can get those single nodes out to all the different development teams. It's a low cost, they buy a small server and they can hack away at it, and everything they do there would be applicable to the large one as well. An HA cluster or a flyaway kit, this is for the tactical or CPTs, and the Air Force is looking at a very similar design right now. We've actually been working with some of the Air Force CPT team as far as these ideas. And then you can scale out to your big one, which is your multi-tenant, high throughput, high capacity, high availability type of cluster. So when we went into this, we said, okay, we need some principles here. If we're going to be investing some internal research and development, we need to start with some principles. One, we're going to use all open standards. Any protocol that we use is going to be open. Open flow as far as your SDN protocols. The hypervisor, we use KVM, Docker, Kubernetes for the orchestration, Helm. We went so far as to say that when we created the marketplace, we created it after one of Google's marketplaces, and we can actually take the platform that we created and link it up to Google's marketplace and deploy Google capabilities onto our platform. It came natively working out of the box like that. And we're not going to be able to show that here because of the time constraints, but over at our booth we've got a live demo if anybody actually wants to see us deploy a capability or deploy one of our tools or Google's tools or whatever. So the next principle was we want to have that app store so that we can create a community of app developers. Again, these apps are, DCO apps. There's a revolution going on right now in the high-speed packet processing, so we wanted to try to leverage that as much as possible. The kernel is the enemy on this stuff, so we wanted to use DPDK, Open vSwitch, FIDO. These are things that are being released right now. Number 4 bullet was really big to us. as much as I love working with vendors, we want to be vendor agnostic. We don't want to require anybody to buy a specific product to use these capabilities. So we went generic x86 platforms. The only trick is that right now there's an Intel network card, the Intel XL710, that is required in order to do a lot of really in-depth stuff. But anyway, that's it's like $500 for the card, and it handles 40 gigs a second. So we're not talking about huge investments here. So with that said, that's kind of the core concepts that we took. I'm going to turn it over to Dan Lowen now, and he's going to talk about some of the specifics of the implementation.
So what we did is we ended up calling it EDCOP, which was Expandable Defensive Cyber Operations Platform, with platform being bold, mostly because that is what we're trying to build, not a specific tool, but a platform. Our goal is to be able to deploy new tools in a very, very rapid manner, within minutes. And we'll actually show a little video of showing us how it does that. It's a hyper-converged platform, so what that means is all your storage, all your networking, all your compute, all built into one and all shared across everything. And then the other thing is we want to be able to give people the ability to swap in and out capabilities and tools. So if, for example, Army decides they like a better tool, it's not a big deal. They just deploy their tool, and Navy, you go deploy your tool, and everyone's happy. So here is why we believe how we fit into the DevOps model. Some of the core concepts was self-service configuration, so users are empowered to actually deploy these tools themselves, and that deploys not only the tools but the infrastructure around it. Automated provisioning, all the networking, storage, all that is automated, built into the different framework. Continuous build is more about the process and how we are doing things. What this allows us to do is build tools as well as the networking and all that, and then we can deploy them, and it's all version controlled in GitHub. We can roll back, we can do all sorts of really neat things with that. Continuous integration, if you think of projects, you often end up building something and then trying to figure out how to integrate it afterwards, all the other tools. That's built in. We'll actually give a real quick demo. You push a button, it deploys an inline IPS. All the events are automatically sent into Elasticsearch, and it just works. So we're not integrating afterwards, we're integrating up front. Continuous delivery, the idea is we want to be able to do the 200 builds a year that our adversaries are doing, not this month-long, year-long build process. Automated release management is configuration. The configuration management and IA process is built in. We can version control everything, and it works. Incremental testing is the last piece. Because we are now able to roll back, we're much more comfortable trying to go fast. So we're gonna test a lot faster than we're probably used to, but we're gonna do it in a manner that is a little bit less risky. So DevOps, the power of one, the wisdom of many. We're trying to allow everyone to start playing. So we have a real small demo or video. What we're showing here on the right-hand side is the little black dots are actually physical computers. The little blue dots are pods, and we're going to actually deploy Suricata. So on the left is our app store. Hopefully this works. Alright, so we hit deploy new app. Hopefully you can see that. We select Suricata. We've actually got documentation. We come in, we deploy. This is pretty cool because we can actually give users the ability to change things. So you want Suricata inline passive, we can handle that. You want Elasticsearch somewhere else, we can do that. So then what happens, you see little blue dots kind of explode out. It takes about a minute or two for Suricata to actually come up. Gigamon senses it, starts passing traffic through. Events are being sent into Elasticsearch, and that's it. Our long-term goal is that it doesn't have to be Suricata or Bro. They're both open source products. You could maybe get someone else. You know, if you want another inline IPS, that would be a possibility. It's all would just be in an app store, whether it's our app store or someone else's app store. So So these are the tools that we currently have working. We're using Kubernetes, which is a project by Google. We're using Docker for containerization. Helm is what's providing the customization. And then there's a tool called Cockpit, which is for managing the cluster. For data management, we're using Watcher, which is an Elastic product that's part of XBAC. Kibana is also an Elastic project to view information. We're able to ingest Windows and syslog. It's actually just a capability you deploy, and then you still have to configure your Windows host and so forth, but to ingest those logs isn't a problem. Suricata and Bro. We are using Gigamon, which is our only proprietary appliance right now. And Elasticsearch is what is now feeding all that information and storing it. Long term, what we would like is there's a whole slew of different capabilities that would just be an option. Sort of kind of go how we do our dev process is we write code. Everything is code. All the software, all the infrastructure, it's all code. It's all available on GitHub. It's version controlled. We push it to GitHub. We then, once we're comfortable with it working, we test it. We then push it to a repository. The repository is versioned, so that allows production to be pulling the old tested stuff while testing pulls the new fun stuff, or maybe some production people want to pull the new fun stuff. So they pull it down, they do all their testing. Once they give it the thumbs up, it moves on to production. And the important thing here is all the platforms are the same, whether it's small or big. Shouldn't matter too much. This is a picture. EDCOP 1.0, it was originally 4 machines. They were 1U units. I wired it, which is why it looks like a mess. EDCOP 2.0, I did not wire. And it's now 6 compute nodes. The compute nodes in 2.0 are actually weaker, but we have more of them. So, but they are commodity Cisco hardware. It should work on pretty much anything, though. We haven't tested on everything, but it's designed to be flexible like that. Some potential use cases, you need more capacity. It's literally installing new nodes. So we've got it so that you drop a new node on, it pixie boots, it builds within about 30 minutes. You have to label it, so that says, I want you to now hold the work of sensors, and the capabilities immediately get deployed. It's pretty easy. New tools and signature development, you just burn and replace. So instead of constantly trying to keep things up to date, you just delete the old and bring in the new. And the traffic handles that without dropping too much packets. It does drop a little bit, and that's one area where we would like to be absolutely seamless. Additional network tenants, being able to handle multiple users. The idea here is now we're not going to try to share tools, but we're going to create a platform that allows the separation and each tenant to actually manage their tools as they see fit. And then network micro-segmentation, kind of the concept of being able to deploy the same capabilities both low, all the way down to the garrison, all the way up to the agency. So next steps, we love to talk tech. If anyone's interested, our booth is somewhere over there. We do have a VPN that has been really, really slow, and you can come and we'll show you how it's working. And is there any questions? Yes.
You've said to be based on open standards, and then you said open source software. They're two different things. Right. Which one did you mean?
The question was that we said open standards and then we said open source, which are two different things. So that's correct. So we tried to use open standards as much as possible. Everything we've done so far has been open standards. We also concentrated on open source as far as what we're calling our reference implementation, because it was freely available and small company on a shoestring budget, we didn't have a whole lot of stuff to work for. So it's both. And at the end of this week, we are open sourcing all the work that we've done, and you can see that it is open standards. When I say it's open standards, it's Helm, Kubernetes, the network overlays that we're using are all open. We didn't write any proprietary protocols or software to do this.
The corollary to that is, and maybe it's not appropriate for y'all because y'all need to build this, is that while you're building, it looks like you're building a DevOps framework. The question is, why are you building a DevOps framework when there are numerous open standards-based DevOps frameworks already out there?
Right. The question is, why are we rebuilding a DevOps framework when there's a lot of frameworks out there? Right. So we didn't find anything that was applicable to doing network defense tools, and that was kind of where we homed in on, was that while right now there's a lot of DevOps standards that can be used for deploying, say, a web server or something like that into Amazon or Google or whatever, being able to deploy an IPS or an IDS, we just didn't see it, and we couldn't find anybody that was doing it. So we had to look at how we would actually apply this to DCO to make, again, going back to as a company, we're a security company, so we look at network defense and perimeter defense in terms of security. So that was really why we homed in on that. Question, sir?
How are you doing your code validation? You're writing.
The question is how are we doing our code validation? We're not. If I'm honest with you, this was a prototype, a rapidly developed prototype, and that's really why we're looking to open source this at the end of the week. Is we've already got it up on GitHub. It's going to be one click in order to give it out to the world, and really we're hoping that we don't have the funding or resources to be able to do extensive code validation or development. So we're really hoping to put this concept out there, let everybody, let the community look at it, play with it, steal it, whatever, and hopefully contribute back to it. And we're looking to use that open source model to help out with that code validation. Any other questions? Thoughts? All right. Thank you guys all very much for coming by.